Hello class, I hope you did well on your tests. I'll be marking them in the next couple days, so I'll let you know soon enough. Thanks for making a good effort this time. I saw lots of people turn their work in on time. Also, we're going to start our next chapter. Our next chapter is on electrochemistry. It's corresponding to chapter 20 on your textbook. You can see I'm at a different location now. I'm going to be here for the next couple days, next few days, until I straighten out some things at home. And then you might see me at my parents' farm. They also have a very nice board. My dad has a large projection screen on the wall, so I can use that to good effect because I'll be able to write larger. Here I'm stuck on the refrigerator. I've never used the refrigerator as a teaching tool before. We'll see how that works out. Anyway, what I want you to do tonight is to watch the videos that I've already uploaded on a playlist. They're old videos, they're from 2011, but they were written at school, so the board has a much clearer view of the notes. I want you to watch the electrochemistry playlist up to part 3. So part 1, part 2, part 3, and then I think there's a part 3A to show you some examples on how to balance electrochemical reactions. Today I'm just going to give you a brief overview of what I want you to know, but your real homework is to go and watch those playlists that are on my YouTube site. So you know exactly what to do because I've assigned these before, and now like never before they're going to be handy because the work's already done. All you have to do is watch and take notes. But I'm going to give you just a quick overview of what you're going to find in there. So briefly, redox reactions. Redox is short for oxidation reduction. What is an oxidation? An oxidation is when a chemical substance loses an electron. Reduction is when a chemical substance gains electrons. There's a way of remembering that. It goes Leo says Ger. So Leo says Ger. Loss of electrons is oxidation. Gain of electrons is reduction. The transfer electrons between chemical substances can be used to produce energy. So we exploit redox reactions when we use a battery. Batteries are composed of two cells, or rather two chemical reactions taking place within a cell, and the two chemical reactions occur with the loss of electrons from one substance whereas the other substance gains the electrons, and that transfer of electrons is forced to occur through an external wire, which is then connected to a device which can be made to do work because the electrons carry a certain amount of energy. The amount of energy that electrons carry we refer to as voltage. So when you have a higher voltage, it means each electron within that current is carrying more energy. The term current simply means how many electrons are passing by in the wire. So there's a rough analogy with the flow of water. Water can flow in large amounts or it can flow with great energy. So if you have a high speed current, that's roughly analogous to voltage. The water molecules have more energy as they're flowing down the river. And then of course, if you have more water flowing per second, that's analogous to the current. So current and voltage. One is measured in units of amperage, that's the current, and the other one is measured in units of volts, that's the power carried by each electron. An oxidation state shouldn't be equated with the charge of the atom, but it has an effect on the charge that you will observe. So, for example, if you have a sample of zinc being oxidized by hydrochloric acid, which is a supply of protons, the zinc will end up having a +2 charge and become aqueous from the solid state. This is also aqueous. And the reaction produces hydrogen gas. So if you were to look at the oxidation state of zinc, originally it's 0, and for the hydrogen it's +1. For the zinc here, it becomes +2, and here for the hydrogen, it becomes 0. So you can see that the zinc goes from 0 to +2, the hydrogen goes from +1 to 0. So the zinc is being oxidized, and the hydrogen is being reduced. Give it some thought on page 849. It says nitrogen is usually negative. Well, let me read you a question first. What are the oxidation state of the atoms in cyanide, Cn minus? So they show cyanide. I don't know if you can see this. I'm going to lower the camera just a bit. Cyanide with a charge of -1. Now, normally nitrogen has a -3 charge, but the whole molecule is a charge of -1. So that, remember we did this in chapter 4. So what is bringing that -3 charge on the nitrogen back up to -1? Well, that means the carbon has to be at +2. And that answers that question. In any redox reaction, you have something that's an oxidizer, and the other thing is a reducer. So on page 850, they ask you a question along those lines. They ask you to identify which one is which. Identify the oxidizing and reducing agents in the oxidation-reduction reactions. So we have 2 liquid waters plus aluminum plus permanganate, giving you aluminum hydroxide plus manganese dioxide. Let me erase that so I can use it. Here's the disadvantage of using a refrigerator. Makes an ungodly mess when you try to erase it. You have to use solvent to do it. Fortunately, being a chemist, I knew which solvent to use. Okay. That'll have to do for now. So let's show the reaction. It shows. This is practice example from page 850. So we have 2H2O liquid plus aluminum solid plus permanganate aqueous turning into aluminum hydroxide and manganese dioxide. Now the logo's getting in the way. So let's look at the oxidation state of each substance. We know that from chapter 4 that a metal in its normal elemental state has an oxidation state of 0. The aluminum in this compound is combined to hydroxide, which is overall -1. But the whole molecule is only at -1, even though there's 4 hydroxides attached to it. So this should be bringing it down to -4, but because the whole molecule is -1, it means this has to be +3. Then, what is manganese's oxidation state? Well, it's next to oxygen. Oxygen is usually -2, and there's 4 oxygens, so you should have a -8 charge on there, but you only have a -1. What that means is this is +7. But when you go to this side of the equation, the 2 oxygens, which are normally -2, would only add up to -4. The whole molecule is neutral, which means the manganese has to be +4. So the manganese in this equation has gone from +7 to +3, so it's gained electrons, so it's reduced. This is the reduction. which means this is the oxidizing agent. It's taking electrons away from something else. So this is the oxidizing agent. Takes electrons away. From other substance. And then if you look at the aluminum is going from 0 to +3. So we'll show that here. That's oxidation. So for oxidation to take place, it means something is giving away electrons. So the aluminum is giving away electrons. It is the reducing agent. Now, I explain this in detail on the playlist that you've been assigned to watch, 1, 2, and 3. So go ahead and do that. Also learn how to do the balancing of redox equations, which is within those notes. So within the playlist, part 1, 2, and 3, I show you how to balance redox equations. And let's see if I can give you some homework. Now, you know what? That's enough for now. I'm going to ask you to simply watch those playlists 1, 2, and 3. Tomorrow, we'll pick it up from there, and we'll see how much progress you've made. Okay, so I'll see you tomorrow.